Okay, this is a review. It's the last review we're going to do for this test. We did give you a practice quiz called Honors Pre-Calc 17 practice quiz. It was something that, yeah, you were supposed to have done for today, and I know some people are still working on it right now in class. And judging by the fact this is a mass today, and I needed to finish up this lab with you, and we worked on that before I started this video, we just don't have time to grade that thing in class. And so I have posted the key for the quiz, and that's one of the #1 things you're going to need to do tonight is check your key, and not just check it like, oh, I got 2 wrong. Figure out what you're doing wrong and fix it, because the test is going to be similar, of course. So use that as a study technique tonight. Go check the answer key that's posted in the keys folder, chapter 17. Okay? So that's one thing to do tonight. Next thing, on the board you see a complex number, and then we're asked to do it to the 5th. I want you to put it in cis form first, and I hope you did, and I hope you went like this. Over 0, down 3, down there, and then I hope you didn't put the cis form as -3 cis whatever. Why would that be wrong? Yes, sir.
Because it can't be negative for this.
Why? Radiuses cannot be negative. Okay. Negative wouldn't work. 3 cis what? Now you might be like, but you said -3 right there. That's rectangular. That's not polar. Polar has to be positive r's. Okay. And now, why can't I say this? 3 pi over 2. Because it went past pi. How many of you groups caught that? Okay, good. It should instead be negative what? Pi over 2. 3 cis negative pi over 2. All right, now, if I want to put it to the 5th, I can demov it. 3 cis negative pi over 2. And demov is about demove of the exponent. And if this is to the 5th, then that 5 needs to not only go on here, 3 to the 5th, it also needs to go there. -5 pi over 2. And, uh-oh, what? It's past pi. So that could have been a right answer, except that that is more than pi. It went past here as it was going around. In fact, how many pi over 2's does it do? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. It's actually back here again. So what should you call it? Not that, but -pi over 2. All right. And then, I know, it's the same as it was before you put it to the 5th. And I know that's a little weird, but it's true. It's kind of like saying 2 pi and 0. They're in the same place. Yep, they are. Yes?
That might be a bad question, but since you're not like finding the 4 roots of it, you just find the 5th one, is that mean you don't have 2 pi k?
Well, it's not a bad question. It's a good question. A lot of people do add the 2 pi k in here because they think there's going to be multiple answers. But when you put something to the 5th power, just think about it with like the number 2. Is there more than one 2 to the 5th, or is there just 2 to the 5th? It's just one of them. There's not multiple of them. So we don't want the plus 2 pi k thing in here. That's only when you need the 4/4 roots of or the 3/3 roots of. Okay? So, and again, that process, since we already did the lab, I'm not going to go over the 4/4 roots. If anybody needs that for the video, you need to go back a few videos and watch it back there. Okay? Because we already have practiced the 3/3 roots of 2 plus I or whatever over and over again. Okay. So, no, you don't need plus 2 pi k because there's not multiple answers. If this is the 5th root, we would. All right, so the final answer on this thing is 3 to the 5th cis -pi over 2. And I did have some people ask, in this case, couldn't I have just put this to the 5th? And the answer is yes, because this one doesn't have an x. So yeah, it actually could have worked pretty easy to just put that to the 5th. That would have been legal, and you could have done it. Its answer is just in rectangular form. And this is the answer in cis form. So that could have worked. All right. Either way, you're going to have to figure out 3 to the 5th, which is a massive number. All right, now, how about factoring? If you can factor, you should, but what if you can't factor? So if you had this would or wouldn't factor? It would, and then you get x plus 2 and x plus 1, and then those are the factors. Are they the solutions? No, what are the solutions? All right, good. So isn't it like this was like this? And the answers, which are -2 and -1, can just go in here. You get what I'm saying? All right, so it's always x minus something and x minus something. And why does that matter? Because what if this wasn't a 2? What if it was a 3? Then it wouldn't factor, would it? But you could still factor it. Because if you can factor, you should. And if you can't factor, quadratic formula. Use that and see if you can figure out how to actually factor this. I'll pause for a second while you try that. Okay, x equals -b, which is -3, plus or minus square root of b squared, which is 9, minus 4ac, 4 times 1 times 3, over 2a, which is 2. 2 times 1 is 2. And then this becomes 9 minus 12, which makes -3. True? And then can I leave it as square root of -3? No. Got to clean that up a little bit. It's -3 plus and minus I root 3 all over 2. Now that is your factors? No, that's your solutions, roots. Okay, now could I now make this into factoring? Yes, you could. In here, you could drop -3 plus I root 3 over 2. And over here, we could drop -3 minus I root 3 over 2. And there, it's factored. It's brutal, but it's true. If you actually did first outside, inside, last, your firsts would give you this, and your lasts, when you multiply this times this, it's weird, but it will give you 3. Why? Because you end up with I squareds that make -1s, and anyway, long story short, it'll come out to 3. And then the outside and the inside together, again, weird, but it comes out to 3x. Notice the h get multiplied by an x, right? So that would work. And it stretches your understanding of what factoring really is giving you, or what factors are compared to roots. All right, so next, what if it was possible to factor by grouping? And you'll be able to factor this next one by grouping. So let's just actually have you do that. Just factor this by grouping first. But then I'm going to have you go back and factor it a different way. And if you want to, just jump right to the different way. I'm going to have you do long division. Because the one, I'll just say it this way. You can't always use factor by grouping. That won't always work. But long division will always work. Yep. If you were to factor it by grouping, do you get there would have to be an x plus 3 in it? So hint, x plus 3 must go into it if you want to do it with long. In a moment, I'm going to ask everybody to do it with long, but if you want to do factor by grouping first, I can show you that. So here's factor by grouping. The x squared comes out, x plus 3. 1 comes out, x plus 3. I know that's a little weird, but it is true that the 1 can come out, right? Then this and this are the same. X plus 3 times x squared plus 1. And if you left it like that, I would cry a little bit and have to mark it totally wrong. You know why? Totally. Yes. That's correct. This is x plus 3 is as simple as it's going to get, but that has to be factored over the complex numbers. And therefore, it's x, and then do you remember this deal? Plus and a minus. And don't forget the square root of 1, which is just 1. I. There you go. The reason I say square root of 1, because what if this was a 3? then you'd have to have square root of 3i and square root of 3i. You know what I'm saying? Okay. The one happens to be this like really clean, neat one where you don't even, it's actually, it's just I and I, but it's actually square root of 1 going here and square root of 1 going there. And square root of 1 just happens to work out to be 1, and then you don't have to even write it. So anyway. All right. So then when we're that far, we have the roots. They're just staring at us. -3, -I, positive I. How many imaginaries did we have? 2. Do you get it has to be in sets of 2? All right. Now, take a look at this. Do long division when you know -3 is a root. Do long division when you know -3 is a root. I know it's the same question, but long division, it's different. What you just did wasn't long division. What you just did, that's called factor by grouping. And I'm aware, it comes out the same exact answer. I'm just trying to show you, you need to know how to do long division. Pausing. I want you to think this through for a second. Why did I put x minus there? Because you can always start with x minus and then just drop in your root. See what I'm saying? Yeah, it turns into x plus 3. And then, if you're going to do long division, you say what goes here so that that times that will equal this. So I want it to be an x squared. And x squared times x makes x to the third. X squared times 3 makes 3x squared. Works out perfect. These are gone. These come down. And then I just have to figure out what goes here so that that times x can make x. Oh, must be a 1. 1 times x, x. 1 times 3, 3. Make them opposites. 0 remainder. Cool, it worked. Once again, is it factored all the way? No. That and that is factored, but it's not factored all the way. It's not factored over the complex numbers, because this part here would then need to be turned into x plus I and x minus I. All right. Now, last thing, and I think this is kind of cool. There's another thing we could tell you was a root. Will you tell me? What is also a root? You've seen the answer twice now. Yes? That's not a root. That's a factor. That's not a root. What's the root? Oh, I is a root. If I is a root, and you also know -I is a root, and then you can build your little factors here. And wouldn't you have x minus and x minus? Yeah. And wouldn't you have plus I and minus I? That's supposed to be an I, not a T. And that means x minus I and x plus I. And that means x squared, what? Plus 1. Now this one's weirder. Would you please try to do long division with this one? I'll pause for a minute. So, I hope that you figured out that this had to be x squared, but a few weird things, or sorry, x, and a few weird things happen. That times that becomes x to the third, but that times that is x. How am I supposed to put an x right here? I'm not. I'm supposed to put it over here. That way, it'll match up. Now, if you used a placeholder, that would have made it work out nicer. Remember how you could have put a plus 0x in there? But I'm going to show you how you didn't have to have a placeholder. This becomes opposite, opposite, and then I bring this down, 3x squared, and I bring that down, plus 3. See what I'm saying? And now all I have left is plus 3. 3 times x squared, 3x squared. 3 times 1, 3. Look at that. It all worked out. I have no remainder. There's my things factored. But is it factored over the complex numbers? No.
It works perfectly.
Yeah, it does.
What did I do wrong?
You probably didn't line up the X in the right spot. All right, now we're not done yet, but we're really close. I have one more thing I want to show you, and that is just this. If I had this number, the 512, do you know the other number? 13, good. 5, 12, 13. Can you tell me if I was going to put it in cis form, what that would be in cis form? I hope so. 13, cis, and of course you all know that angle, right? No, but you know what to write then. Kind of tangent, but it's not tangent. Think about it. Talk to your neighbor. I'm going to pause for... All right, it is inverse tan of tangent is TOA, right? Opposite, 5 over adjacent, 12. Inverse tan of 5/12. There, that's another way to write that if you don't know the angle. You can write it as tangent or inverse tangent. Because tangents don't find out angles. Inverses find you angles. Like if you were going to put this in a calculator, it would tell you the angle. If you put in a regular tangent problem, it needs an angle and it would tell you the side ratios. So this kind means I want an angle. So it would figure out an angle for you. This is the angle. Okay, that's all the review I have for you for today. Again, I strongly recommend you use the key that I posted to check your quiz. And that's all I have for you for tonight.